Okay, so today we're going to look at section 5.3. Good little reminder here for us. We're going to want to be able to consider and utilize the first quadrant angles in the unit circle, namely 30 degrees, 45 degrees. I would add to that 60 degrees. Obviously, 60 is a multiple of 30, which makes sense. However, they give us the pi over 6 and the pi over 4. So we know 30 degrees is pi over 6, 45 is pi over 4, and 60 degrees is pi over 3. So that pi over 6 to pi over 3 relationship may not be as easy for us to see as that 30 degree to 60 degree. So if we're trying to figure out a way that we can come up with 15 degrees using the 30, 45, and 60, obviously a couple different ways we could do this. We could do 45 minus 30 would give us the 15, or we could do 60 minus, 60 minus the 45, which would also give us the 15. I'm going to jump down to number 3 to 75 degrees, because that's a little bit easier again for us to see. So again, 30 plus 45, pretty obviously, is going to give us 75 degrees. Now the pi over 12 is a little bit more convoluted to see by looking at the pi over 6, pi over 4, and pi over 3 radian measures. So what we can do here, since we have that as over 12, let's take all these and convert them. So let's take pi over 6, and we can say that that's the same as 2 pi over 12. We can take pi over 4, and we can say that that is the same as 3 pi over 12. And lastly, we can take pi over 3, and we can say that's the same as 4 pi over 12. Now, if we're looking for pi over 12, as we are here in example number 2, it might be a little bit more easy for us to see that if we were to do 4 pi over 12 minus 3 pi over 12, that would give us 1 pi over 12. So that's going to be the same as doing pi over 3 minus pi over 4. Okay? So anytime you see that over 12, think about doing this idea that I've done in green, where you convert them all to a denominator of 12. So again, 5.3, sum and difference identities. Again, I'm going to try to give you a couple mnemonic devices here to help you remember these. The ones that I kind of use a lot are sine keeps the sign, and that's an SIGN, and cosines stick together. Okay, so sine keeps the sign, and cosines stick together. So as we look at these sum and difference identities, we have the cosine of a sum or difference. So again, they put the plus and the minus together. I've tried to expand this a little bit. So what we want to think here is cosines stick together. So that means we are going to look at the cosine of the first angle, in this case u, cosine again, because the cosines stick together, of v. Now minus, so if this is a plus sign in, we have a sum, we're now looking at a subtraction. So remember, the signs keep the signs, which means the cosines do not get to keep the sign, if that makes sense, SIGN. And now we're going to have the sine of the first angle, in this case u, and then the sine of the second angle, in this case v. Now looking at the cosine of u minus v, again, we do not keep the sign, SIGN. It's going to change from a negative to a positive. But again, those cosines are going to stick together. So we have cosine u, cosine v, and then sine u, sine v. Okay, so again, cosines stick together, but they have to change the SIGN sign. So, using this cosine of a difference identity, we want to find the exact value of cosine of 75 degrees. So from those warm-up problems, we know that 75 is the same as 45 plus 30. So we would rewrite cosine of 75 degrees as the cosine of 30 degrees plus 45 degrees. And it should not matter. It won't matter if you do 45 degrees plus 30. So now remembering that rule, not going to go back to the rule. I'm going to try to remember the mnemonic device, which is the cosines stick together. Okay, so this we're looking at now, the cosine of the first angle, which is now 30 degrees. Cosine of the second angle, which is 45 degrees. Change the positive or negative sign, so it's going to become a minus. And now we have the sine of 30 degrees and the sine of 45 degrees. Now, each one of these has a value. Cosine of 30 degrees, cosine of 45 degrees, sine of 30, and the sine of 45 degrees. So I'm going to do the easy ones first, because I know that the cosine and the sine of 45 is root 2 over 2. So now I'm left to find the sine of 30 degrees and the cosine of 30. We need to remember our unit circle here. For 30 degrees, we're going to be going out a lot and up a little bit. So we're going to be root 3 over 2, comma 1/2. So our cosine value is root 3 over 2. Our sine value is going to be 1/2. When we multiply these together, the square root of 3 times the square root of 2 gives me the square root of 6 over 4 minus the square root of 2 over 4, which gives me the square root of 6 minus the square root of 2 all over 4. Okay, that's the exact value. We don't want to simplify that or plug that into our calculator and get any type of decimal there. That's the exact value in the answer we're looking for. I will point out you're going to see the root 6, the root 2, and the over 4 a lot, because remembering from the unit circle, we don't really have a whole lot to choose from. We're going to see these numbers, and then we're also going to see root 2 over 2 semi-regularly. Okay, so you're going to want to keep that in mind. You know, the sign might change. A different value might be 2 minus root 6 over 4. So you're going to get to see those numbers a lot. So don't be surprised if a lot of those answers appear similar. Okay, now the sign of sum or difference, remember sine keeps the sign. So you'll see here when we're doing the sine of u plus v, we keep that plus sign, that positive sign. Okay, so now we're going to have to split the sine and the cosine because it's not a cosine angle, so the cosines don't stick together. So we're going to wind up with the sine of the first angle. Okay, so this is the sine of u, cosine of v, plus, now we're going to switch that around. So I usually will write this as the cosine of u, sine of v. It's up to you if you want to maintain your sine cosine order, or if you want to maintain the order of the u and the v. Totally up to you. Since we're multiplying, the order doesn't matter. For the second one, we're going to have the sine of u, cosine of v. Keep the positive or minus sign right there. They're both negative. And then we're going to have sine, well, I guess I'll maintain my cosine of u, sine of v. Okay. Again, the order of these is entirely up to you and what you prefer. Okay. So we want to write the following expression as the sine or cosine of one angle. So what we're going to do is we're going to look at this and we're going to try to determine, well, is this a sum of sine, a sum of cosine, a difference of sine, or a difference of cosine? So the first thing that I look at here is that the cosines are not together. Okay, so this is going to be the sine of a and of a what? Well, if I remember with sine keeps the sign. So since I have a positive sign there, I'm going to have a positive sign right there. And I'm doing pi over 3 plus pi over 4. All right. So now we're going to want to add that together. So we have the sine of, we need a common denominator. In this case, is going to be 12. And we're going to have 4 pi over 12 plus 3 pi over 12, which gives us the sine of 7 pi over 12. Okay, so in the previous example, we were given this, okay, and we had to come up with this. Now we're just working in the opposite direction. Okay, so again, sine of 7 pi divided by 12. Positive sign, and then the sine and cosine tells me it is the sine of a sum. Now, tangent, again, there is a formula for this. I kind of choose not to use it, not to memorize it, not to use my brain to store that information, because I can come up with that. I know that with my previous information, previous stuff that I know, the tangent is sine over cosine. And I know the sum of sine and the sum of cosine formulas, remembering that sine keeps the sine and the cosine stick together. So I can come up with this sine u, cosine v, plus or minus, etc., etc. Now looking here, what we've done in order to get to this simplified version is divided everything here by cosine u, cosine v. So we divide everything by cosine u, cosine v. Even this stuff up here has to get divided. Cosine u, cosine v. Divide this. Cosine u, cosine v. Okay? So starting in the, we kind of have 4 different little problems here to simplify. 2, 3, and 4. So if we start here with this first one, we can see sine of u over cosine of u is going to give me tangent of u, and cosine v over cosine v cancels out, so that's going to give me this tangent u right there. Moving over here to this second box, we have the cosine of u over the cosine of u, so that's going to cancel. Sine v over cosine v is going to give me this tangent of v. Cosine u over cosine u cancels, cosine v over cosine v cancels, giving me the 1. Over here, let's see, we have sine u over cosine u, so that's going to, this right here is going to give me tangent, and then sine tangent of u, and then sine v cosine v is going to give me the tangent of v, giving me this final part. So again, you're welcome to memorize this. However, the amount of times that you wind up using it, I think it's a lot easier to just derive that formula or to find that value whenever you might need to do so.